In this part of the video, we're going to do examples 4 through 8. And our goal in these examples is to try to simplify everything into one of these 5 answers here, okay? So typically a good way to start this is by trying to turn everything into sines and cosines. That's one method of simplifying trig identities. So we do have our reciprocal identities. So I know that I can rewrite cosecant as 1 over sine x. And then sine x is already as simple as it's going to get. You're never going to get simpler than sine. So I know that these guys cross out, so I'm left with just a 1. So that is one of the choices there. So we got to what we wanted to get to. Cotangent, I wouldn't use reciprocal because it's not in terms of sine and cosine. If I did that, I get like 1 over tangent, and then secant 1 over cosine, and I'm not going anywhere. So that's kind of a roadblock. But I do know that cotangent is the cosine divided by the sine. And then the secant in the reciprocal identities is 1 over cosine x. You'll notice these guys cancel. So now I'm left with 1 over sine x, which is not one of our choices. But I know by the reciprocal identities that 1 over sine is equivalent to cosecant x. All right, with this one, whenever I see the squareds, I think automatically I'm going to go to the Pythagorean identities. So I do know that secant squared is equivalent to 1 plus tangent squared. So I'm going to try that. So I'm rewriting this. And then I am substituting in this Pythagorean identity, 1 plus tangent squared x. I'm going to distribute the negative in front. So tangent squared x minus 1 minus tangent squared x. The tangent squared minus the tangent squared cancels, and I'm down to -1, which was one of our choices. All right, the next one, a little bit different. I'm going to leave cosine squared as cosine squared, but I'm going to try to replace this. Whenever I see a squared and a 1, I'm kind of thinking Pythagorean identity, okay? So actually, I'm going to rewrite this a little bit. I'm going to go 1 over cosine squared x. I'm separating my fraction, equals cosecant squared x minus, or times cosecant squared x minus 1 over 1. So I recognize that I've got cosecant squared, but I don't have cosecant squared minus 1. So I could take this guy and subtract him to the other side. So cotangent squared theta equals cosecant squared theta minus 1. Do you notice how this and this are the same? So that means I can replace it or substitute in the cotangent squared. So 1 over cosine squared x times cotangent squared x, technically over 1. Now, I know that cotangent can be rewritten as cosine over sine, and we're not worried about the squared. If it starts with the squared, just keep carrying the squared. So cosine squared x over sine squared x. Then you notice the cosines cancel. I get 1 over sine squared x, which again is not one of our choices. 1 over sine squared reduces to, with the reciprocal identities, cosecant squared x, which is one of our choices. All right, finally, we've got tangent x times cosine x. I'm going to write tangent in terms of sines and cosines. So tangent is sine over cosine x with the quotient identities times cosine x. My cosines cancel, and I reduce to just sine